Hey, good afternoon, and thanks for joining us in our Improving Talks, where we get to kind of talk about different technologies and things happening in the IT world. Today, we want to talk to you about DevSecOps and how it's more than just a fad. But just to start, I'll introduce myself. My name is Erik Bowmans, and I'm Vice President of Technology here in our Atlanta office. And one of the missions that I have in that role is to help us develop the DevOps practice that we want to bring to our clients and to help encourage that as an industry thing. Momentum that we want to push forward. So as we think about DevOps and as we think about security, those are two things that are very important together and that we want to make sure that we think about not as disparate fields, but things that we bring together. And so that's really the point of this talk, is to talk about DevSecOps as a unified practice and how it can help you as an industry. So with that, that's probably taking a step back and thinking about what is DevOps. DevOps comes from really a background of a world where development often was in its own silo and operations was in another. And so what that means is, as developers, I'm thinking about how do I write my code? Does my code work? But I'm not really thinking about how I operationalize, how I run my code in production. That's the operations team problem. So really, I just have to hand my code over to them. They've got to figure out how to get that live and support that. If there's problems, all of those things become operations issues. So it can really lead, because of that siloed approach, it can really lead to a difference, even conflicts really between people as they're thinking about, well, it's development, not my problem if the production system doesn't work. Production's like, well, it is your problem because you wrote the code and it seems to be a code issue. So how do we align those things? How do we recognize that the application, the system, the enterprise that we're supporting is really a unified system? Development and operations are two parts of that system. They have to work together. And so DevOps says, how do we unify that? How do we create a common framework, a common language really between the two groups, and reduce the friction, and that way really speed up things. And so as we're thinking about DevOps, what it really comes down to is creating the idea of a shared responsibility and shared accountability between originally developments and operations, but as we talk through today, really all the different stakeholders and hosting this enterprise system. So shared responsibility, right? We're in this together. I'm writing code as a developer. I'm hosting code as an operations and an environment. If we aren't sharing that responsibility, it's not going to go well, or it's going to go slowly. And likewise, shared accountability. When systems fail, it's not just the operations problem, it's not just a development problem, but again, how do we share that accountability and work together to resolve those things? DevOps really does lean heavily on a strong agile principle, right? The point here is I'm writing code, I'm deploying code, development versus operations. I want to do that more efficiently, I want to do that faster. And so agile talks about how do we always deliver value to the customer as we produce software. How do we lean on concepts like continuous integration, continuous delivery, and continuous deployment as technical approaches to do that, so that the idea of I'm writing software, that software goes through a process, that process then produces a production deployment that then produces value to the business or to the customer, right? DevOps was born from that world to reduce the friction between the handoff from developments to operations, but it is still rooted strongly in those Agile and CI/CD practices. So still key part of that, but just a different way to think about that common language. And when it comes to common language, it really is the idea that a developer starts to have to think more like an operations person. As I write code, how do I make sure that my code can be easily deployed? How do I make sure that once it's deployed, it can be easily troubleshot in production? So what am I doing as a developer to help that operations person's job more successful? Likewise, an operations person also has to start thinking more like a developer. So how, as I'm receiving that code, how do I automate the deployment of it? How do I automate the infrastructure around it? All those different things that may have been manual processes in an old operations world, how do they become more automated? To be more automated, it means I'm scripting things out. I'm actually writing code now. It's not just the developer's world to write code, but also becomes the operations person. So again, that mixing of the mental model of developer, think operational operations, think more development, and unify those different processes together from a DevOps perspective. So as we're thinking about how do we do all those different things, how do we get code faster from developers to operations to production, The answer is automation, and we're going to dive quite a bit into automation in a bit later. But if you're not automating tasks, then you're basically always going to have some inefficiencies, always going to have some problems of, it works on my computer, but not in production. Well, how do we get it to production? Well, somebody had to go manually install some DLLs, some files, all those sort of manual processes contribute to friction, contribute to problems that DevOps is trying to solve. And so that's why automation really is a key component of DevOps. Another key component of DevOps is the concept of shift left. And shift left really comes from the recognition that errors, bugs, problems always get more expensive the closer they get to production. So if we're looking at a concept of shift left and we're thinking about the cost of a bug, right? If we're in the requirements phase, that's all the way at the very beginning. If the requirements that we're defining have a problem, it is very easy. It is very inexpensive to fix them then, right? We're writing a user story and we realize that user story is not going to deliver value. We can revise the user story. The cost was that product owner, that business analyst time to edit the requirement, to edit the user story, to get it right. So very, very low cost. We've only really involved one person, one group of people. And so we really haven't committed true cost to that story. Then we moved on to development. So a developer, they take that user story, they start writing their code. They start looking at how do I implement that? As a human, we're going to make mistakes. We're going to write a bug. We're going to have a mistake in the code. But if we catch that as a developer, again, very quick time to fix it, very easy to fix that error, detect it, replace it with the correct code. As I'm writing my unit tests, I'm using unit tests, test-driven development, again, to fix errors as a developer in that phase. It's more expensive than the requirements phase because I've actually probably spent a lot of time writing code. I've spent time writing unit tests and now I'm finding those issues, but it's still a pretty cheap place to catch that bug because it's not really gotten anywhere off of my development environment. It hasn't been shared with other users, haven't even gone to testing to QA to find out other issues. Then the next phase, it is ready for testing. QA gets it. They do their job. They find issues. They report those back to the developer. Again, a great place to catch these types of issues because we're still far enough left that the costs are lower. They're not as low as they used to be because now we've involved another team. We've spent more time on this feature than we had before to write the tests, to automate those tests, to get the results, report them back to the developer. The developer has to go back and work on that. So again, we can see the costs slowly incrementing, but again, it's a great place to catch an issue. Then QA passes, doesn't find a particular issue. Now we're in pre-production. That's the fourth stage on this graph. And again, since we're not in production, it's okay. We've found an issue. We've identified it through some smoke testing or something, but the costs now have gone quite a bit from further left, right? And the reason there is because we are in pre-production. That code was going to go to production. We were more or less ready, signed off, but we can't now. We've got to roll that all the way back to the developer. So we've, at that point, involved developers, we've involved QA, we've involved some of the production deployment teams. So this is a bigger deal than it was when the story began. But again, it's not in production. No customer impact, no huge cost that we're seeing. That final step, when that bug or whatever that problem is hits production, that's when the cost just can skyrocket, right? It can be from causing customer issues, which could in turn cause more customer support costs. It could be a security issue that has huge ramifications to the business. So the cost of finding a bug in production is just enormous compared to finding that bug or that problem at any stage earlier in the life cycle. So shift left says, what do we do? What can we do as a practice, as a business, as a software development team to shift that risk analysis, that bug finding, that issue detection as far left as possible, so that we are keeping those costs lower, but also as a result, moving code, higher quality code out faster. So shift left really is a key tenet here, and it's going to become even more obvious how that ties into DevSecOps as we unpack that union. So one of the things that we're thinking about, right, is how do we get code out faster? How do we get code out with higher quality? DevOps with continuous integration, continuous deployment, continuous delivery recognizes a world where a story can get written, code can be written for that story, tested, and then once it's approved, go straight into production without any other intervention, right? Because we've got enough automated testing, we've got enough other processes in place that we know that once the code passes those screens, which are automated, that code's going into production. So we can, with a continuous deployment world, really always be releasing code. So big software shops can do multiple releases every single day because they've got the systems that can take the new code and get it into production quickly, which is great from a fail fast approach, right? Because that means even if you think about shift left and the cost of that bug in production, that bug in production isn't going to live long, right? It's going to, if it's found fast enough, if the fix is identified fast enough and can be pushed through the process, you might be able to fix that in the next release. So it could be a matter of minutes to hours, right, that a bug lives. But still into production, there's still costs. It is disruptive because of all the things that happen, but it's not as big of a concern, right? Because we can move that code quickly and fix that and fix it in the next release. However, all that doesn't really work well when we talk about security, right? Because there's no good argument, there's no moment in time to say, well, a security problem's in production, but it's okay, it's only there for an hour, right? That is something that is potentially shut down in business worthy, depending on the security bug. So DevOps, we're moving code faster, it's more efficient. Security says, well, hold on now, let's not be so efficient, right? Because we can't have a security problem go straight into production without any sort of checks and balances. And so DevSecOps comes into being to say, how do we get security injected into the DevOps process so that we can keep the efficiency and not at the cost of security? So what does that really mean practically, right? So DevSecOps, we're now adding security. We're now giving the CSO as an organization a seat at the table, so to speak, as part of the product development team, not as an outside office that only comes in at the beginning or the end to double check things, but a true participant in the DevOps lifecycle, a true participant in the agile process to write code. So we're no longer saying, well, what are the security requirements at the beginning or even security at the end, where we're just, let's do a penetration test or a vulnerability scan right before it goes to production. That's all security needs to be involved with, the beginning, the end. Let's move from that security first mindset to really what we call security always, right? So how are we thinking about security as we're building out a software development team at every phase? So we talk about shift left from writing requirements, development test, pre-prod and production, right? Security has to be present and mindful at every one of those stages so that we are always thinking about security, no matter where we are in that life cycle. That is how we make it faster, right? It's by having every single step of this process the opportunity to correct things before they move along the path. So that is the idea. We stay fast, but we still stay secure because we have security present at every step. And so what that really comes down to, again, DevOps unified the development team and the operations team. There are a lot more stakeholders in software development than that. And so DevSecOps says, let's also make sure the security team is part of that group. And that way we are always aligning our software development lifecycle, not just on delivering value, but delivering value securely. Think about DevSecOps. The need of security always really does become something you can almost just kind of a no-brainer, a logical way to think about things. So what does it mean how to implement that? How do I think about DevSecOps in a way that I can actually practically add that practice to my team today? And the way to think about it is it's not just a practice, it is a set of processes, a set of procedures that people have to follow, but it's also a set of technologies that you may not be using today that have to be added to that process to help us enable the practices and also automate them in a way that, even though we're adding more work to the effort to build software, that work is automated so it doesn't translate to longer time or more human cost to the project. So DevSecOps really is both a practice and a technology approach to solve those problems. So from a practice perspective, what does that mean? We talked about security always, and that is fundamentally the concept that we want to think about here. Security at every step. Think as I'm writing the requirements, what does it mean to have a secure product? What kind of authentication, authorization, compliance rules? Do I have to have encryption at rest? All the sort of requirements, right, have to be baked in at the very beginning. the developer has to understand what it means to write secure code, and we'll talk about that in a bit. So that as they write the code, it's done securely. The tester not only is testing for the quality or the acceptance, but also security. We'll talk about that in a bit. And then finally, production, of course, is where security often lived. So we're still there. We're still making sure we're setting up a secure environment, which we'll talk about here in a bit as well. But again, every single stage, we've got security. Security always is present, always mindful of what we need to do. So what does that really translate to? There's several security philosophies that we want to talk about and how they apply to DevSecOps. The first is assume breach. So if you're not familiar with that phrase, it is the security practice that says we're not going to find every single vulnerability in our software. It's effectively impossible because it's a constantly shifting landscape. We'll find out about a vulnerability in the library like the log4j a few weeks ago, but we won't find out about that till tomorrow. So today we thought everything was great. Tomorrow there's a vulnerability that we've got to address. So the assume breach says let's accept that reality because not only can we not find all of them at once, the bad actors on the other side only have to find one of them. So sitting here today in production, you may have 500 vulnerabilities that you maybe know about some and you're working on patching and mitigating, compensating controls, and you may have a ton of others that you don't even know exist yet. It's your job as a security professional to protect that resource, to find all 500, but that will take time. The bad actor on the other side, they only have to find the one that gets them in, that gets them started and gets them down the path that they're going to use to do whatever it is they want to do to your system. So assume breach, assume that they already have found it. How would you know? Could you look at your systems today and see, well, that behavior doesn't make sense. What's going on there? Let's investigate and find out. Is it an actual compromise? Or is it just a bad hard disk in a RAID array, right? All those sort of things have to be things that you can pay attention to. So assume breach says implement processes and technologies that let you understand what normal looks like. What does my application look like when nobody's messing with it and then it's under normal load? And what does abnormal look like? So how do I know that all of a sudden traffic spikes change? It's now going to a different country than it used to, all those sort of things. Assume breach says understand what normal looks like, use technologies to detect the abnormal. And so that typically is done through security incident event management, SIEM software, which sits to the side of your application, your enterprise environment. It's gathering the logs from all those things, and it's consuming those logs, and it helps understand a baseline. And then it also starts to detect and report anomalies so that you can have a single pane of glass where you can see what does normal look like, what does abnormal look like, and start to detect and react to this so that when you do see something come up that doesn't make sense, you're able to investigate and find out, is it, again, a compromise or is it a different type of anomaly? But either way, we're paying attention. That's the sysadmin. That's more of an operational perspective. Now, from a DevSecOps, what are the developers doing to help enable that assume breach? And that really comes down to coding practices and architecture so that as I write code, maybe I was logging errors and things like that, but am I doing it in a way that is meaningful to understanding proper use of the application versus improper? Likewise, do I have instrumentation in place? Am I using technologies like application insights from any of the providers that offer that to understand what's actually happening inside the code? What are slow points? What's normal look like? So developers, it's not just about sysadmins making sure that systems log, but also application developers making sure applications log and are instrumented in a way that we can actually do some analysis. The next practice that we want to layer into our DevSecOps is defense in depth. And so really, again, if you're not familiar with that term, it is the idea that every layer from the most to the edge all the way to the center has some sort of security in place. So think of it like a bank, right? A bank, when it's closed, the outer doors are locked, so you can't go in the bank. Well, if you break through those doors and you're inside now, the vault also is locked, and that's another layer that has defense. Once you get in that vault, if you want to get in a safe deposit box, it's also locked and keyed. So just to get from the outside all the way to the contents of a safe deposit box, you have to break through 3 layers. That is a nice concrete, literally, example of defense in depth, right? Because breaking in only gets me so far before I have to break in again and break in again. And that helps us when we think about the assumed breach idea that, well, if there are 500 vulnerabilities I'm working with, they're probably not all straight line, right? So just breaking into one of those vulnerabilities probably doesn't get me all the way to the center of my system, that defense in depth is also going to step in there and help. Well, this vulnerability let them get this far, but now they still have to work their way to what their target is. And so the exercise still is in play with how do you go from the outside all the way in. Defense in depth is there to help prevent that. The third security philosophy that we want to talk about is zero trust. Zero trust is probably the newest of these three. A lot of attention right now. Folks like Microsoft are definitely incorporating it into all their products. But zero trust really takes a step back and says, there's activity coming to my system. How do I know that it's even valid? Like, how do I know that a traffic to my web server is the traffic that I want to support? What do I have in place from a defense in depth and an assumed breach perspective that helps me understand that traffic is legitimate? And so the zero trust says, don't trust it. Assume that it's not legitimate. Let it make the effort to prove to you that it is. And so an easy example of that is in the Microsoft space in particular is your Office 365 logins if you use that product. And so Microsoft uses zero trust on Office 365 logins today. If you log into that from your office, corporate network, well-established protocols from a company laptop, there are things in place that Microsoft has been informed by your employer or your system administrators are legitimate sources of access. And so from that perspective, to get to my mailbox, I probably only need my username and password. If I then go to the computer down at the hotel desk, it doesn't have all those. It's a different location. It's not a company issued device. And so now I'm logging in. I don't have as many things in play to trust you. And so I'm going to add some complexities to that cycle. Multi-factor, for example, I'm going to pop up a message on your phone saying, are you really trying to log in, right? That idea of, because it's the number of things that I trust are smaller, I need to build that trust back up to the point that I let you in. And so zero trust really, from a initial authentication standpoint, says, how do I ratchet up and ratchet down the authentication steps required to even know that you are who you say you are, so that I can then begin to trust you. But it doesn't end there, because it also, beyond authentication, looks at the authorization. So great, you've proven that you probably are who you say you are, even though you're sitting in a hotel lobby. Do you even have permission to do the thing you're trying to do? Is it view your mailbox? Probably. Is it administer the system? Maybe not, right? And again, if I were sitting at my computer where I always do that, then maybe I passed the threshold and it does let me in. But zero trust says every time you try to do something to any system that you've encountered, even though you authenticated and validated at the first step, do it again when you change context, if you will, when you change what you're trying to access, right? If I walk through the front door of the bank, great, that's okay, because they're open. If I try to walk in the vault, somebody's going to say, excuse me, are you allowed to be back here? And so same thing, as you access that next layer, there's probably re-authentication that's going to happen. So you've probably seen this with a lot of products. If you have administrative rights, log in to use the product, no problem. Username, password, it's great, you're in. Try to access the admin section and say, hang on, can you do some multi-factor here so that we really know you are who you say you are? So zero trust really lets us have that idea that we have to build trust to even get in, but we have to reestablish that trust at every additional layer. Zero trust is often contrasted against VPN technologies in the older days. And in fact, you'll see that in some recent breaches over the last 12 months where VPNs were a part of the problem, but not the only part. Zero trust counters that. So in the VPN situation, I, a user, need to use my username and password to connect my computer to my corporate office. The VPN says, great, you've authenticated, you are allowed through the door. And maybe your VPN has multi-factor, which is great. That's an important piece of that. But in either case, the reason it's not zero trust is because I'm now on the company network. I have gone from blocked access to doors are now open. And so if, depending on how the network is segmented or set up, I've got pretty much network level access to anything that I can get to. So I can go visit servers, I can interrogate them, I can test different things because the VPN just says, hey, he was allowed through the front door. What he does after that, not my problem. And so zero trust says, doesn't matter that you got through the front door. Prove to me that you actually belong where you're trying to go. Prove to me that you have access. and I will ratchet that up proportional to the sensitivity of the information you're trying to access. So it's a great philosophy, and when you can see how it layers into the idea of defense in depth, right? Because I'm re-authenticating at every layer in that, and it also ties into the assumed breach because it's actually paying attention to what normal behavior is, using that to establish a trust pattern. It detects the anomalous behavior and uses that to ratchet up the type of things you have to do to reestablish trust. So it is absolutely plays well into the other philosophies that we have from a security practice. All right, so those are some core security practices that we have as we're thinking about how we architect. And just like assume breach had a role for the developer, defense in depth has a role for developer, because again, as I write code, I need to be thinking about authentication, authorization, and whether I want to do that. The zero trust does as well, right? As I write my application, as a developer, as an operations person, am I putting the right pieces in place to leverage these philosophies? So while these may have been traditionally part of that security office's concern, in DevSecOps, shared responsibility, shared accountability, developers, operations, and security professionals all have to be thinking about all these practices as they do their jobs. As we shift kind of gears, though, toward practices that impact people in the organization, the first thing to always have in place, and it's pretty common now that it's present, is the idea of security awareness training. Assume breach, defense in depth, and zero trust are great when security professionals have them, and you have bad actors trying to thwart them. They can become very useless very fast if your internal team doesn't have the training and the awareness to know what good security practices are or not. So if laptops are left unlocked, for example, well, now the laptop is logged in, and zero trust doesn't have anything to do with it. Defense in depth doesn't have anything, it's already inside. So just the idea that when I step away from my computer, I lock it so that somebody else can't sit down and have my access. That's security awareness training, right? That I don't click links and emails, that I don't do all the things that we all know we shouldn't, but that becomes a part of the fabric of me as a user, as an employee. But that applies to everybody. That's the entire organization. We need to take that one more level as we think about the development team, the testing team as well, and do additional training, right? So it's great to know, don't write your password on a sticky note and put it on your monitor. We all should know not to do that now, but also as a developer, how am I writing code that is more secure, less vulnerable? And so doing any sort of secure development training becomes a key part of that. OWASP is a great organization to enable that. It's one of the ones, for example, if you're doing credit card, PCI DSS security, that's more or less required for that program, but it becomes a very universal approach to any sort of secure software development, even if you aren't required to have it for a security standard. Having your developers and your QA and your operations team understand what this is like, what it means, just becomes a key part of the practice that you want to apply. Then we have another drop down in terms of approach, and the way to think about software development specifically is peer reviews. So we're going to talk about automation. We talked about continuous integration, continuous deployment, continuous delivery, right? As an idea that I write code. If I do the right thing, that code can go straight into production with almost no human intervention. Well, if we're using a product like Git, for example, to store our code, we probably have some policies in place that say, well, that's not entirely true, developer. You can write your code, but it's not going into production until you do a pull request. And then we have somebody who reviews that and works with you to say, did you meet our standards? Some of those are automated, actually. So we're going to see that in a bit, some of the ways we can go into that peer review, that pull request with a ton of information preloaded because of automated processes. But that's a check and a balance in the process that says, I wrote code, it goes to production automatically. Slow down just a bit. Let's do a peer review. Let's make sure that a second person has eyes on it. And really when that comes down to is the second idea here, separation of responsibility, right? Secure code assumes that I, as a developer, can't actually directly influence production without other checkpoints in the process, other people. So, for example, if I were compromised, whether it's because I've become the bad actor or the device I'm working on has become compromised, so I'm innocent, but my device is now the bad actor. There's got to be another check in place that says that thing that you are trying to send to production looks kind of fishy. Let's look into that. Let's figure out why. Separation of responsibility basically helps enforce that so that A developer should conceptually never actually have personal access to production. A QA tester should not. The only people that have access to that should be a very small thing, and as we talk about automation, could be down to 0 humans actually have access to your production because we've automated it so well. But the separation of responsibility says, as a developer, write the code, put it into the process. As a QA tester, test the code, but don't write it, right? Don't fix your own bugs. Don't do your own testing. Don't do your own deployments. That's the ideal state for a software development team. It is also a difficult state though to be in for a smaller organization. And so there are technologies out there that help us enforce the separation of responsibility, but with a smaller team where people have to wear multiple hats. So privileged identity management, for example, lets a user, lets a person go check out production credentials so they can do the production deployment, but they check it out. It has an approval log or an approval process, so they can request the access, but their manager has to approve it, or operations team. It's logged. The fact that they asked for it is all recorded. So again, it lets that person change their hats and do their job, do different jobs. When we want separation of responsibility, we don't have a big enough team, but it still keeps the separation of responsibility in play so that we actually have it. The appropriate controls in place. As a developer doing their daily job can't influence production, they've got to go do an extra thing. And the other thing that does, because we're logging it, because we're auditing it, it introduces the kind of the last practice from a security always perspective, traceability. Traceability is valuable enough that I wanted to dive into that a little bit deeper. So traceability is the idea that I know the state of production backwards in time, all the way to the beginning of when the idea first came to me that what should be in production. So a little side note, traceability is supported by all your major software development platforms, Azure DevOps, the Atlassian suite, the Amazon equivalent, AWS. So you probably already got the technology in place to enforce traceability. So this says leverage that and go from the moment the feature, the story, whatever, the idea comes into being and is written down. Let's tie that all the way through the entire life cycle, all the way into production. So the code that was written, the tests that were performed, both quality and others that we'll see in a bit, all those different things are being tied back to that original story, to the production, to the approvals, to the peer reviews, to the checkouts and the privileged identity management. It's all tied together so that everything in production, and if we're doing infrastructure code that we'll talk about, even the configuration of the equipment in production, all is traceable back to that original story that made it need to exist. That is a huge thing when it comes to understanding what's in your production environment, understanding why it's there from a security standpoint, from an audit, from a disaster prep, all those sort of concepts that matter from a security practice. Traceability lets us understand, well, why is that feature there? Why can people do that behavior that doesn't maybe pass a sniff test later? Again, because we didn't shift it left when we wrote it, but we at least can trace it back to the story and say, I get it. I understand why it's there. Maybe it's wrong, but at least I know why it's there and how to fix it. And so what's great about this, because it's traceable, because it's being logged, that's also data that I can feed into my SIEM. So the SIEM was my SIEM breach thing earlier. It's logging everything. It knows what normal is, what abnormal is. So for example, if a user story is moving through, the code's being written, and all of a sudden Bob from accounting has done a production deployment. Well, that's not normal. The SIEM detects that and creates the alert, and you can investigate why a person who probably shouldn't have had access to begin with, but also, even if they did have access for a legitimate reason, shouldn't have been the one who did the deployment. You now have the alert, you can now investigate it. So again, we're trying to tie all these practices together in a unified perspective that gives us better visibility, better understanding of our environment. And so traceability is a key part of that and ties greatly into the SIEM breach approach. That's our practice. That's the things that we want to do as people, as we think about how we write software, as we think about how we, as custodians of software, owning it, running it, deploying it, all things that we want to do. It's an incomplete story, though, without technology. And so you absolutely have to leverage technology to make all those practices more effective, more efficient, and ultimately successful. And so really what that comes down to, as I said from the beginning, automate everything. And at this point in history, you truly can automate pretty much everything in your environment. Build, for example, is continuous integration. The idea that I have a build script, we'll talk about some of the technologies that I can do this in a bit, but I can do an automated build so that code is committed, it's built. Code is ready for a pour review, it's built. Code is headed towards production, it's built. And that lets me lean into concepts like build your binaries once, an idea that says the binaries are the code in its runnable form, right, on the server. That's what's in production from a binary perspective should also be what we tested, should also be what we did our integration and development testing on, right? There's the idea that I wrote code, it built, great. Well, then I later wrote different code. I'm sorry, I didn't write the different code, but I deployed different code because it came from a QA system. All right, we tested that code. Well, I built it again for production. Now I actually, if you think about it, have code in production that's never been tested. It should be very similar to the code that was tested in QA, which should be very similar to the code that was in the development, but it is actually not the same code inherently. So the idea is build your binaries once because you have a build. That package then is what then moves in through the process, and we do that through automating our deployment. As we're automating our deployment, there's a lot we can do there. And so if you're using a product like Azure DevOps, for example, there's a whole deployment pipeline section. Code deploy from AWS, Atlassian has it as well. So I'm not just deploying the application, those binaries that I built once, I'm also deploying configuration because how the application connects to resources should be different in a development, a testing, and a production environment, right? Those lower environments should not have the ability to access production data. They shouldn't even have the ability to understand what it means to connect to production data. Like if you have connection strings, that you use SQL authentication, hopefully not, but if you are, those should not even be things that are aware of the process when it's in development or production, because we've automated our configuration as well, right? We're actually able to, as part of the automated deployment, take those binaries that came out of the automated build, combine them with configuration that we store in a secure vault, and then that is what we actually push automatically out to the infrastructure. And what's great here is we also can at this point deploy the infrastructure. We can use the infrastructure's code as a way to automatically understand what the infrastructure should be and build it as part of our deployment pipeline. So I wrote code, that code goes into an environment. The environment didn't even exist at the time I wrote the code, but in the process of going through the automation, code is built into binaries. Those binaries are then deployed as an application to an infrastructure that I've automatically created, to a configuration that I've automatically built, all through automation. So the developer can click a button, pull request can be approved, and within minutes, an environment that never existed before, built completely to spec, can exist and be hosting the code that I've just written. And that's just kind of a great place to be, as we'll see in a bit. All right, finally, automating tests. Most larger groups are definitely already have some sort of QA automation in play, typically around quality and acceptance. So if we're using, again, talk about products in a bit, but Selenium is an example of a quality or acceptance test. It runs against deployed code, it exercises the application to see if it does. Testing automated has to be much sooner for thinking shift left. It begins at least with the developer, if not all the way back to the story writer, a product like Gherkin and behavior drift and develop BDD, which we're not going to talk about today, but that's the furthest left we can shift things. If we at least start with the developer, they're writing unit tests, and those tests at least prove to them that their code does what they think it should do. And that's before we ever get that code even off of their development environment into a shared environment. Integration testing then lets us make sure, as we do the automated builds, that my code works with other people's code and that code works with other systems. And so we can actually start to see, if I depend on an API, I can do some integration tests to make sure that my dependencies line up. We can't forget about performance testing. Does this application perform under load the way we expect it to? How do you do a performance test if my development environment is a little box under my desktop? The production is a 20-core system. Infrastructure's code. I can automatically deploy an environment that mirrors production in a cloud environment, do performance testing, get the results, and tear that down. And so even though it's the same scale as production, because it's infrastructure's code, because I can stand it up and just tear it down very quickly, my actual cloud costs can be very low. So we talked about quality, we talked about acceptance. Again, these are very common areas to automate. And the one that comes in today from a DevSecOps perspective is security testing. There's multiple ways to do that. Static code analysis, for example, can look for common vulnerabilities in your code as it before, and that's part of your build process. You can also do vulnerability checking, static vulnerability checking for libraries that may be out of date or libraries that may have known exploits, like Log4j, for example. There's products out there that during the build process look at your code, look at your libraries, and say, hey, did you know you're running a Log4j version that's got an issue? So you can fix that all the way left at the development cycle, because again, we've done some security tests at a static level. That's part of our build. Then we deploy that code. Now we can do some dynamic vulnerability testing, again, through an automated process. So we can actually have dynamic vulnerability scans run as part of our automated build and deploy. So the code is deployed. It is in an environment. That environment may be exactly like production because of infrastructure as code. And now we're doing actual live vulnerability testing. So it could be OWASP, for example, has a product called Zap that can execute predetermined vulnerability tests. It could be third-party products that also do the same thing. But regardless, those products are coming in. Those products are testing your live environment, finding the results out, and then reporting back. And we haven't even gotten to QA yet, right? We're still in that ready for QA stage of our lifecycle. So we have shifted all of these tests all the way back as far as we can and still be practical. So that is the power of automation. That's why we can shift things so far. That's why we can do so much more testing, so much more quality, so much more security practice without really raising our human costs, because we've automated. And so what that really translates to, in the end, the idea, we talked about infrastructure as code, configuration has configuration as code, security has security as code. And that is the idea that we can script out, we can have code that defines our security posture. Because it's code, it also is part of it's traceable. It's part of our Git repo. It's part of a thing that we do peer reviews on. So infrastructure is code, configuration is code, security is code, all have the exact same benefits that regular software has, all the benefits of traceability, all the benefits of testing. We can do unit testing on infrastructure as code. We can do unit testing on security as code, right? Because it's code. And so the whole thing becomes very reflective on itself, that we can now take the practices that we want to expand upon and apply them to themselves, because we've automated so much, because we've done so much as code. Real quick, kind of run through what some of the technologies that map to these are. So if you're using Azure DevOps and you're doing automated builds, then you're doing YAML, even if you don't use the YAML version. There's still YAML behind the scenes. YAML stands for yet another markup language, but nobody cares about that. YAML really is a thing that it's a great language from a build perspective. Other products have some other languages out there as well. If you're, for example, in a non-Microsoft world, configuration as code, tons of products out there for that. Popular ones, Ansible, Chef, Puppet, there's a ton more. Microsoft is even got their own PowerShell driven version, desired state configuration, DSC. But the idea is these are going to be products that make sure that my environment is configured the way it needs to be to accept my application. And so infrastructure as code, Terraform is by HashiCorp, is a great kind of third-party product that works in all environments. CloudFormation is one from AWS specifically. Bicep is Microsoft's replacement to ARM, which is the old way to write infrastructure as code for Azure. And there's others like Pulumi out there as well. And then automated testing, like I mentioned, Zap for security, Selenium is one. My automated testing team would rattle off 5 more that are current and kind of key players in that environment. But think about the story that we're telling ourselves now, right? Infrastructure is code. It's code that deploys my environment. It's tied to stories. Now I have a blank environment. Configurations code is going to configure that environment to make sure that certificates are deployed to servers, that web server Apache or IIS is configured the way I need to host my application. And finally, my build and deploy pipelines are going to put that code on place. So I've built from zero to a full running application through these automated technologies, and I've tested it along the way. So that's our technology. That's our automation. That's what makes us able to follow the practices that we've been talking about in a way that is very consistent, in a way that's very repeatable, in a way that's very secure and traceable. So all sorts of great ideas from a technology standpoint mirrored to practice. Here, it has to be thought of as a unified effort, right? We are not here to automate out the world of software development, right? There are absolutely going to be people-driven processes as well. People provide the creative aspect to this, right? Developers are creative, QA testers are creative, deployment teams are creative. The whole team has to bring that human element of thinking of the things. What are the cases that we didn't think of that we can't automate that are too complex for automation? So it's great that we can automate. It's great that we can have so many processes in place that let us take that code and get it into production so smoothly, so quickly. But without people, it's not going to work. I mentioned earlier the idea that people don't have access to production, right? That's where some of the true brilliance can come in from these processes, right? So we use people where we need to, where there's a creative element. We then be very intentional about keeping people out where we don't need them to go. So production environment, for example, your users of that application have to come in through a well-defined port. If that's the only access that people have, then that has made it very, very difficult for bad actors to find any backdoors, right? If there's no, well, if you connect to the secret port, you can remote control the server inside the secure box. No, why are we remote controlling a server if we've defined it with configurations code, if we've defined it with infrastructure as code? There's really not a good reason to log onto a server to do something. If it's logging properly and feeding into a SIEM, I don't even need to troubleshoot a problem on the server. Again, we're making a lot of assumptions that we're in a place where this is all true, but it's a great place to be for that reason, right? Because the fewer holes there are to troubleshoot production, the fewer holes there are to configure production, the fewer holes there are for a bad actor to get into production. And the reason we have so few holes is because the entire environment actually was created by automation. And so we don't actually need, there's not really a strong business reason for people to be in production. So the unified effort up until that point, then we let the machines take over, right? But not completely take over. All right, so all that really gets us to kind of this unified goal, this vision that we've been talking about, right? We're talking about shifting things left so that we're catching those issues early, so that we're fixing them all the way back at story writing to development. But what that means and what the automation technologies we've talked about today really give us is the opportunity to move faster, because we know so much more about our software that we're developing at such an earlier stage. So we talked about purity, we talked about doing a pull request. And so as we think about all the different automation technologies, right? Shift left gives us the ability to know that I'm a developer, I write code, I've committed that code to my repository. And so that trigger, whether it's committing to the repository or whether it's a pull request, it kind of doesn't matter. But that's triggering the build, that's triggering the deployment, that's triggering all the automated tests, both static and dynamic, for every push, right? For every pull request. And for every time I want to do a deployment approval, we're triggering all of our tests. And if you look at the graphic here, I'm developing code, great. I'm ready to move it along to the next stage. But great, we're going to build it. We're going to do unit tests. Do those pass? We're going to do static code analysis. Does that pass? It does, great. Use infrastructure as code, stand up a just-in-time environment for that single build, right? That I just triggered. And so that we now deploy the code that we want to understand more about to an actual just-in-time environment. And again, it's not that implausible that it's a production equivalent environment. It could be smaller if it's cost required, because it's only going to exist for minutes. It could be production scale. I've deployed, I'm in production, I'm in that production-like just-in-time environment. Now I test it. Now I run all of my security as code tests that are dynamic. Now I run my automated quality and acceptance tests. So what that means is that code I developed, I built, I deployed, I tested it all just because I committed it to the branch or just because I did a pull request. And what that means is if I'm doing a pull request with a code review, the person who's reviewing the code already knows that the code that I'm reviewing builds. It passed all the unit tests, it passed all the static code, dynamic code analysis and test. It passed all my automated QA and acceptance tests that I wrote. And really, that means that code, for all intents and purposes, after I do my creative human review, is ready for production. And so it is a fine thing to allow it to go to a continuous deployment, continuous delivery cycle and go straight into production. And so that is our goal, right? To think about security, to shift those things so far left so that the last time a human has to think about the code or even the production environment, is that moment when we're doing that review together and thinking about where the things kind of come together. And so with that, that is how I approach DevSecOps. That's how I think security can integrate as part of the whole life cycle. And so that we, again, unifying the practices, secure practices that we talked about, we're unifying the automation technologies that we talked about into that cohesive whole that really does drive finding problems, identifying and fixing problems as far left to save that money, but not just to save money, to move it faster with more quality, to move it faster with more quality and security. And so with that, Justin, that is my material. So if you have any questions, I'm open to that at this point.
We do have some questions in the queue. And if
Okay,
you
great.
have a question right now, then feel free to type that in. Got a few more minutes here. All right, first question is Docker containers come up a lot in conversations around DevOps. How do they fit into the DevSecOps, and how can the containers be used in a security always way?
Yep. Yeah, no, that is a great question. And in a couple of different versions of this, I actually do talk about containers at an earlier point because they are a great technology enabler. I went back to this particular slide though, just to see where they fit in, right? Containers, whether it's Docker or not, just generically containers, are really a great way to separate the binaries, the idea I built my binaries once, and the configuration into a package, and that package then can move through this lifecycle, right? So I'm developing in a container. Great. That means that it's very easy for code that I've written to move forward through the process. The build reestablishes that container. That container is what I'm deploying to my target environments. It really, think of it as, greasing the skids almost, right? All the things that we talked about are incrementally easier if you've already accepted containers as part of your application architecture. They really do play so well into all the other things that we've talked about. In addition, one of the things that they actually do well that isn't talked about a lot is they can also be signed. So if I have a container, if it's passed all my tests and it's approved, it is actually signed digitally, like with a certificate. And now that container, as it moves to the thing, I can actually make sure it hasn't even been tampered with or altered, which is something you can do with code as well, but is a more inherent native part of container technology. So that, let's say that containers are all the way in production, and somehow something happens to it. A bad actor manipulates it, or it gets corrupt through machine error. The orchestrator can say, oh, you don't pass signature anymore. I'm going to kick you out. I'm going to go get back to the container registry, grab a new container, and keep on trucking. And so without ever, again, no human intervention, right? It's automated. There's a little bit of self-healing that containers bring. So it's a great question, and definitely a key component that deserves some attention in this world.
All right. Next question is, what is the best way to get a DevOps team to start thinking with a DevSecOps mindset?
Yeah, so I think it does come back to one, kind of establishing some baselines of why do we need to do this, right? Most people understand the need for security, but helping them understand the context of it. Is it a HIPAA compliance? Is it PCI DSS? Is it something else, right? Helps level set why are we even doing this? But then also, if you have a security professional, if you have a CSO, inviting them to the table, literally, if it's a physical world, right? Helps the DevOps team know that there's a thing to think about, a topic to have. Ultimately, though, where we have to head with that is back to the idea of security training, right? So yes, security awareness training is a key part, but more the secure development practices. So your DevOps team needs that security training. OAuth is great for web development. There are equivalent sort of training options for operations for developers for DevOps, but to think through the different security concerns. Again, it's easy to think about security as, well, I just got to keep bad guys from getting my system. Take that another step. How are you going to do that? What are the sure, you got security professionals who are going to put in firewalls, but what am I doing as I automate the code, as I treat code for infrastructure as code, for build configurations code, as I start to think about those as a DevOps professional, how do I then cycle those through the same security life cycles that the developers have to do for their code? So it is that iterative approach from why to train some fundamentals to adopt the practice across the team. So I think it does become, again, shared responsibility, shared accountability, shared security across not just DevOps, but the whole team. Great question. What else we got?
I've got one more. So if
Okay.
someone is a developer but wanted to get into DevOps or DevSecOps, where would you recommend going for resources and learning?
So you're a developer today, and you want to go out into DevOps or DevSecOps, right? What resources to learn? Easy answer is there's tons of training resources on the web, right? You can Google that. You can find portals like Udemy, YouTube, tons of videos out there. This one will be on YouTube, for example. But really, more practically, if you're a developer, you're already thinking in a code mindset, right? So start thinking about the next step out of, well, what does it mean to do automated build? Do you know YAML? Go learn YAML. Do you know infrastructure as code? Go learn Terraform or CloudFormation if you're AWS, ARM or Bicep, or if you're a developer, Pulumi, maybe a product to think about. So learn that infrastructure as code, learn that configuration as code, because those are the tools of automated DevOps, right? So, and it's typically a relatively low shift for a developer to learn it. They're not programming languages. Some of them are, and some of them actually do use programming languages to implement things, but they are still developer geared thoughts. So by learning those technologies, you are effectively ready to do DevOps, right? Because most DevOps needs are around think like a developer, but help us build the infrastructure and build the automation, all those things, so that the deployments can go, so that they can operationalize. Never hurts to learn something like PowerShell. Never hurts to learn bash scripting if you're in a Linux environment, but those are things that are going to help from an operation standpoint to get into that mindset. And then the security, just find the security tools that your organization uses, or that or WhatsApp or something else out there, and just understand how those products work and how they fit into it. So that's my recommendation for what skills to add to your current list of skills. All right. Anything else from questions?
I think that's it. I just have one more note, is if you're watching this and you would like to review it or watch any of our past live streams, all of these go on our YouTube channel. You can just search for Improving Enterprises, and the channel will come up, and this one will get posted on around Monday or Tuesday next week.
Great. Well, I think we're landing perfect on time. So thank you, everybody for attending. Appreciate that. Great questions, and we'll look for you on the next one.